Hi, in this video I will be talking about this chemistry transition course, and this course is designed for those who was in Form 3 but then you are going to become a Form 4 student and also taking chemistry as one of your electives. So this note can help you to build up some solid foundation on chemistry, which will be able to help you better adapted or better equipped for the Form 4 chemistry courses. So these are all the topics that I will talk about, and perhaps I will divide this course into separate videos. So let's get started. So first of all, we will talk about types of compounds. And for compounds, first of all, you remember that compounds are pure substance made by two or more elements, and they are chemically joined together. All right? Now we have two types of compounds. We have ionic compounds and covalent compounds. In our course, we will first talk about ionic compounds, and we will go into a little bit more details about ionic compounds. For covalent compounds, we will simply talk about some examples. For details, that would be Form 4 discussion. Okay? Now, first of all, we want to know, if you give me a compound, how can I tell whether it is ionic or covalent? Now, this part helps you to identify whether you are looking at an ionic compound or covalent compound. So here, we say that metals and nonmetals, they form ionic compounds. Right? And then nonmetals and nonmetals, they will form covalent compounds. Okay? Now remember, for elements, we have three types. We have metals, nonmetals, and semimetals, right? So for those elements that belong to metals, when they come across with a nonmetal, then they might form ionic compounds. If you have a nonmetal element come across with another nonmetal element, then they are able to form covalent compounds. Okay? Hey, what about metal and metal? Well, metal and metal, they do not form compounds. Instead, they form a mixture called alloy. Now remember, mixture is not compound. Mixture consists of two or more substances that they are simply mixed together. They are not chemically joined. So alloy is a mixture, not a compound. Okay? So you see down here, metal, nonmetal, they form ionic compound. Nonmetal, nonmetal, they form covalent compound. Metal and metal, they might be able to mix together to form alloy. Alright? Now down here we have some actual examples. Some of them you may already know. For example, sodium is a metal, chlorine is a nonmetal, and they are able to react to form sodium chloride. Zinc and oxygen, again metal and nonmetal combination, gives you ionic compound. For these are non-metal. So nonmetals, they will form covalent compound. Okay? Now you notice the name of the compound have slight changes when it compares to the elements. You notice that for the non-metal part, the suffix is changed. Okay? Especially for the later word, not the first word. So here, sodium chloride, chloride, INE become IDE. Oxygen. So here, IDE again, oxide. Here, carbon monoxide, again, IDE. But you notice the carbon, which is the word at the front, does not have to change. So you won't have like carbon monoxide. No, we only change the suffix of the last word of the compound. Okay? Hydrogen chloride, right? Now, you may ask, what elements are metal? What elements are non-metal? Well, we can go to the last page of the note and kind of refresh your memory. Now this is a periodic table. Now remember, metals are on the left, non-metals are on the right. And in between metals and non-metals, we have some semi-metals, or we call it metalloid. So it will be best if we know where the metalloids are, then we are able to tell which are metals, which are non-metals. Now for metalloids, that includes boron, silicon, germanium, arsenic, stibnite, and also tellurium. Okay? So this yellow part forms like a boundaries, like a semi-metal boundaries. So anything on the left would be metals, anything on the right of this boundary would be non-metals. And these bunch of things at the bottom, they are all metals because you see the stars here, they are branching from here and here. So these should also be on the left-hand side of the metal of the periodic table. Okay? So this is how you can tell whether an element is a metal or non-metal or even semi-metal. Now let's quickly go back to page 3. So now we have some practice question here. Now for all the practice question, I will have answers attached in the description below, so you can check. But of course, my advice is you first attempt the question yourself and then you check the answers. If you simply copy the answer, there's no meaning to that. Okay? Now here, basically, you're given some elements and you will decide if they are going to form a compound, what compound will it form? Will it form an ionic compound, covalent compound, or they will not form compound at all? Alright? So I will do 1 or 2 as an example. Now here, you can tell hydrogen is a non-metal, and non-metal. Fluorine is also non-metal. Okay? So non-metal and non-metal, they will form covalent compound. Covalent compound. Okay? Down here, sodium is a metal. Oxygen is a non-metal. So you can tell they form ionic compound. Okay? Just like that. Alright? So you can finish off all the questions. You can pause the video first and you check the answers by downloading the marking scheme. Okay? So now I will move on to the next page. Okay. Now, like I said, we will focus more on the ionic compound in this transition course. So before we learn about the details of ionic compounds, perhaps we need to learn more about ions first. So here we want to talk about names and formula of ions. Now, first of all, what are ions? Now, ions, they are simply charged particles. Charged particles. Remember, I talked about it in Form 3. In Form 1 science, we talk about particles being tiny substance, right? Particles. And under the category of particles, we also have atoms. So atoms are particles. We also have ions. And we also have molecules. Okay? Now, atoms, of course, is the smallest particle, smallest unit of matter, right? Ions, they are charged particles. Whenever it has a charge, be it positive or negative, it belongs to ions. For molecules, we are talking about several atoms joined together to form an entity, to form a body. Then that one is called a molecule. For example, water, H2O. H2O, 2 H's plus 1 O joined together, it forms a water molecule. Okay? So ions are charged particles, and if we have a positive ion, then we call it cation. If we have a negative ion, we call it anion. Okay? So bear in mind of these terms. Now down here, we want to know how to name ions. How to name ions. So these first 3 rules are talking about positive ions, and down here, these are talking about negative ions. Okay? So let's have a look. Now, for positive ions, the name of the ion is the same as the element. Okay? Very simple. So if you have an ion formed from sodium metal, then it is called sodium ion. Okay, magnesium, then magnesium ion. Just like that. Okay? Now here, for some metal cation, they could have different charges. For example, for copper, it can form copper 1 ion, copper 2 ion, with 1 plus and 2 plus respectively. For ion, we can have Fe2 plus and Fe3 plus. So if you are dealing with a metal that can exhibit more than one charge, then you need to specify the charge by using a Roman numerals in the name, like copper 1 ion, copper 2 ion, iron 2 ion, iron 3 ion. Okay? If you don't put down these Roman numerals, people have no idea which ion you are talking about. Okay? Now, for the third one here, these are actually some special case because some positive ions are made by non-metals. Now, most of the positive ions, most of the cation are made from metal elements. However, there are some exceptional cases, like these three. These three ions that are made by non-metals. Now, for these non-metal cation, the name of the ion will end with IUM. IUM. So this one, ammonium ion, hydronium ion, nitronium ion. Okay? So these are some special case. At least I want you to memorize this at least. Okay? Now down here for anion, for negative ion. So for monatomic anion, for monatomic means single atom ion. Okay, single atom ion. For example, like this one, N3 minus, O2 minus, F minus. You see, one atom only. So these are called monatomic ions. So for monatomic anion, the ion's name must end with IDE. Must end with IDE. So you see, nitride, oxide, fluoride, phosphide, sulfide. Okay? So you need to spend some time really memorizing the spelling. Okay? Now down here, just now I have monatomic anion, so single atom anion. And down here we have polyatomic anion. Basically means more than one atom. Okay, the ions containing more than one atom. So here for monatomic anion, very often they have oxygen. They have oxygen inside. Now here, I understand it's not easy to generalize. So I just try my best to generalize what we have here. Now, you can first look at the examples. You see, this one, we have NO3 minus, NO2 minus. Okay? Now you notice, NO3 minus has more oxygen than NO2 minus, isn't it? So if it has more oxygen, then the suffix will be ATE. If it has fewer oxygen, then it will be ITE at the end. Okay, so ATE, ate, is the past tense of eat. So eat a lot of oxygen. So if it has eaten a lot of oxygen, then we put it ATE. This is how I memorize it. Okay, let's look at another example like sulfate. Again, SO4 2 minus versus SO3 2 minus. 4 more than 3, right? So the one with 4 oxygen, ATE. The one with fewer oxygen, ITE. Okay, can you see the pattern? Now phosphate ion, you see PO4 3 minus, here PO3 3 minus. Again, the one with more oxygen, ATE. The one with less oxygen, ITE. Okay? Now here, this is some other example which does not follow the rules. Okay, we have carbonate ion. This one is called hydrogen carbonate ion. This we have to memorize it. Now down here, this is the most complicated one. Now, just now the ITE, ATE applies here. So ATE, ITE. 3 oxygen is more than 2 oxygen. That makes sense. But it also contains 2 more different ions. We have ClO minus and we have ClO4 minus. So here for ClO minus, we call it hypochlorite ion. Hypochlorite ion. Hypo means less. So that means this one is even lesser than chlorite ion. So that's why it is called hypochlorite ion. And perchlorate, per means too much. So perchlorate ion, it contains even more oxygen than chlorate ion. So that's why it is called perchlorate ion. Okay? Now, I understand this might be difficult to accept at the beginning since we have so many vocabularies, right? But if you want to have a better learning in Form 4 chemistry, these are the basic stuff you need to be very familiar with. So that's why try bit by bit to learn these formulas. Okay. Now on the right hand side, now these perhaps some of you may be interested with. So these are basically all the cation and anions that is common. But you see, altogether it's like 30 something of them. And I have separated based on the charges because some ions could be positive 1 charge, some will be positive 2, some will be positive 3. Now all of these, to be honest, you need to memorize. So it would be best if you start to memorize it, or at least you have some impression of these names and formula, so that when you step into Form 4, you feel more comfortable. Okay? Now, just one more thing I want to remind you is that if you notice, now the charges plus 2, plus 3, but when we put down the symbol, the ionic symbol, you notice the charges was written as 2 plus, 3 plus, okay? And here, don't write down 1 plus, you simply put down plus, okay? So this is something that you need to follow. This is like the rules that you need to follow. If you put down like Cu plus 2, no mark will be given, okay? Similar idea goes for anion as well. You see, negative 2 charge is written as 2 minus. Negative 3 charge is written as 3 minus, okay? So this is something I want to remind you. Now also, you notice that some ions are black in color, some ions are purple in color. So the one with purple color, you notice that they are made up of more than just one atom. So those are what we call the polyatomic ions. Okay? And the others, made of one atom only, we call it monatomic ions. Okay? So these are all the ions that you need to know. Okay? At least in Form 4. Now next page. Next page here, again, you see 30 practice question. Basically, you are asked to identify the ions coming from the compound. So judging from the name of the compound, you need to deduce what ion it contains. Okay? So I can do some examples for you. So for the first one, you see potassium bromide. So like I said, the positive ion does not change the name. So potassium, okay, is simply K plus. Okay, K plus. Okay? And you also notice that the positive ion is written at the front, negative ion is written at the back. Okay? Now here, bromide ion. Now remember, the negative ions ends with IDE. Okay? So IDE here, monatomic anion. Bromide is coming from bromine. Okay? So this is actually Br minus. Okay? So K plus Br minus. Now the charges, how can I know? Well, I memorize it. That's it. Okay? Now, what about number 4? Copper 2 sulfate. Now you notice we see the Roman numerals here, right? So the 2 tells you about the charge. So we are not talking about Cu plus, we are talking about Cu2 plus. Okay? So this one is Cu2 plus. And sulfate, notice ATE. ATE means more oxygen. So sulfate will be SO4 2 minus. Okay? Is it difficult? Yeah. At the beginning, you will find it very difficult. But once you are getting more familiar, comfortable with those ions, then it takes like 2 seconds each, to be honest. Okay? Now, I will leave the rest up. I can also do some practice on the next question because this one you are translating from name to symbol, which is a little bit easier. Down here, we're doing the reverse. We are translating from formula back to name. So, for example, this one, okay, CaO. So, Ca at the front, this one must be calcium ion. Don't put down calcium, it should be calcium ion, okay? And then O, don't put down oxygen. This one should be oxide ion, IDE, oxide ion, okay? So we can also have a look at perhaps 19, okay, 19. So 19 here, Cu, CO3. So Cu is copper, okay? So you will put down copper. Hey, but hold on a second. Copper has two ions. We have copper 1, copper 2. So is it copper 1 or copper 2? Now, to tell whether it's copper 1 or copper 2, you also need to pay attention to the N ions, the negative ion. Now the negative ion, CO3, here is carbonate ion. Let's put it down first. Carbonate ion. Okay? Now, carbonate ion, if you go back to the previous table, you know it's CO3 2 minus, right? 2 minus. So if you want to balance the charge, or if you think that it is Cu plus, then you think about it. Plus and 2 minus altogether will be 1 negative, isn't it? Will be negative 1. So it doesn't add up because for ionic compound, they carry no charge at all. So the charges must be balanced. In this case, you must have Cu2 plus, okay? So once you can tell that it is Cu2 plus, then the name, you should put down copper 2 ion, okay? Is that clear? Now I will leave these questions for you. Again, pause the video, attempt it yourself, and check the answers by yourself, okay? Now the next few pages are very colorful. If you have a color printer, or if you want to print it out in color printer, that would be best. Now basically here, after you have memorized the name, the formula, now it is the color. You need to memorize the color, okay? So this table is showing you the color of common ions, okay? Now the good thing is most of them are colorless, okay? Especially the negative ions. Most of the negative ions are colorless, okay? And we are talking about in aqueous state. That means when dissolved in water, okay? When dissolved in water. Now because for ionic compound or for ions, they could have different color when it is dissolved in water or when they are in solid form. So we are talking about these colors in aqueous state when all these ions have been dissolved in water. Okay. Now, first of all, like I said, most of the negative ions are colorless, and a lot of the metal ions coming from group 1, group 2, group 3, they are also colorless. Okay, like sodium, magnesium, aluminum, these are all group 1, group 2, group 3 metal ions. They are all colorless. Okay. Now, perhaps we need to pay attention to some ions that is colored. Copper 2 ion is pale blue or simply blue. When we are in Form 1, we perform crystallization. We make crystals, isn't it? And by that time, we are basically using copper 2 sulfate solution. So that's why the crystal appears blue. Okay. Now, next one, cobalt 2 ion is pink. Because do you remember, we have something called dry cobalt 2 chloride paper, which is used to test for the presence of water, isn't it? Now for that paper, it is blue in color. Once it comes across with water, then it becomes pink, which is basically the cobalt 2 ion dissolved in water, so it is pink in color. Now for iron 2 ion, it is green, pale green. For iron 3 ion, it is yellow or brown in color. Okay? Chromium 3 plus gives you a very intense green color, Manganese 2 ion gives you very pale pink, almost colorless. In reality, you may not be able to see that pale pink color. Okay. On the right hand side, only two negative ions that have color: dichromic and permanganate. Okay, one is orange, another one is purple. Both of them have very intensive color. Okay. Now on the right hand side, this basically shows you the real color of those solution. Now I can tell this one is actually too green. In reality, it will not be that green. Okay, actually iron to ion in reality is almost colorless. The green color is so faint and pale. Okay, now look at this manganese 2 ions, almost colorless, right? So we call this one very pale pink, right? Now you see the intensive color of dichromic and permanganate, also chromium ions, very intensive color. Okay. Now down here, some common ionic compound. Well, just to give you some more authentic ideas, actually we're dealing with ionic compounds in daily life. Like this one is when you have stomach ache, you would take antacid pellets to neutralize excessive stomach juice. We're actually taking manganese hydroxide. Limestone, you have learned about that. Coin bleach. Coin bleach used to clean the clothes or used to clean the floor, right? Potassium nitrate in gunpowder. Okay. So very recently there is a tragic accident appears in Lebanon, right? The huge explosion near the I think the coastline of Lebanon, right? And that is due to the excessive and inappropriate storage of ammonium nitrate. And potassium nitrate is something similar to ammonium nitrate, okay? But they are like having similar uses. Calcium chloride is a drying agent. This one, calcium phosphate, is actually the building material in your bones and enamels, right? You know, our bones, out of 97% by mass of our bones is actually calcium phosphate. It's a very strong material, you can tell. Sodium sulfite for food preservation. It is also added into red wine to prevent them from spoiled. Baking powder, sodium hydrogen carbonate. Because when you heat it, the sodium hydrogen carbonate will decompose to give carbon dioxide. And that will make the bread dough rise, become spongy. Okay? Ammonium sulfate, this one is often used in chemical fertilizer. Okay, chemical fertilizer. Okay? You don't really have to memorize all of them, but these are very common example. I would say this one is some basic daily life chemical knowledge. Okay? Now the another 2 pages is also very colorful. This one, we want to talk about colors of ionic compounds. Now, for ionic compounds, after all, they are made by ions. So most of the time, the color of the ionic compounds can be deduced from its constituent ions. Okay? Now, for example, here, sodium chloride is made up of sodium ion and chloride ion. Knowing that sodium ion and chloride ion are both colorless, so the compound would appear white. Okay, white, not colorless, white. Okay. Now here, copper 1 oxide. Copper 1 oxide, this one you perhaps need to memorize it. Okay, copper 1 oxide has a red color. Copper 2 oxide. Now, even though copper 2 ions in aqueous state is blue, oxide is, well, colorless. But when they come together, they become black. This is some example that you might have to memorize. Okay. Down here, copper 2 sulfate, we have 2 forms. One is hydrated, one is anhydrous. Basically, the hydrated form is the one you form after crystallization. So there are some water trapped inside the copper 2 sulfate. And then here, this is anhydrous. Basically, when you put this into an oven, you heat it so that you drive off the water trapped inside. Then, without those water trapped inside, it will appear white. Okay, so 2 different colors. But most of the time, when we're talking about copper 2 sulfate solid, we are talking about the hydrated form, the blue form. Okay? Copper 2 carbonate. So copper 2 carbonate gives you a green color. So green and blue is similar to one another, but the anion may change the color a little bit. But knowing that carbonate is actually colorless. So the color is mainly due to the copper 2 ions. Now here, cobalt 2 chloride, just now I just mentioned it. It is pink when it is hydrated. That is the same as the cobalt 2 ions in aqueous state. When they are in anhydrous form without water, it appears blue. This is exactly the dry cobalt 2 chloride paper, right? When it is dry, that is anhydrous, then it is blue. When they come across with water, then the copper 2 chloride becomes hydrated and therefore appears pink. Okay, and that's why we can make use of cobalt 2 chloride to test for the presence of water. Okay. Iron 2 hydroxide gives you a green precipitate, green solid. So forget about those solutions. We are talking about the solid here. So iron 2 hydroxide is green in color due to the iron 2 ions. Iron 3 hydroxide gives you a brown to yellow solid. Okay. Now these are all solid. Actually, all of these that I'm showing you, they are solid. Okay, because ionic compound is a solid. They must be solid unless they are dissolved in water. Okay. Sodium dichromate. So sodium ion has no color. Dichromate is orange. Therefore, the solid is orange. Similarly, potassium permanganate. Potassium ion has no color. Permanganate is purple in color. Therefore, the solid appears purple. Now this one is a tricky part here because you notice that dichromate is orange and then copper 2 ions is blue. So when blue mixed with orange, at the end they give you green. I don't know why, but this is what they have at the end. Okay? So this is basically some example showing you that the color of ionic compound can somehow deduce it from its constituent ions. Okay? Alright, so I will stop here and we will continue on next part.